Okay, friends. Now next topic is electric field lines and its properties. Now what is electric field lines? Have you ever seen the electric field lines? No. Okay, we can see the electric field lines? No. How electric field lines look? Can you imagine the image? Can you imagine electric field lines? We only see the pictorial form of the electric field lines. So one question is our in mind: how electric field look like? Okay, now the visualization of electric field in the pictorial form is known as the electric field lines. Okay, so we can only the visualization of the electric field. Now there are some electric field properties. Okay, just we have to see that. Okay, now the electric field of vector or electric field vector E is always tangent to the electric field lines. So now the electric field of vector is always tangent to the electric field lines. I'll see the example. This is one of the example. This is the electric field lines. Okay, now this is electric field line and this is a electric field. It is a electric field. The electric field is tangent to this point. Now this is the second property. Now the second property is the number of lines per unit area are perpendicular to the square of proportional to the magnitude of electric line in that region. Okay, now so here one of the example, the imaginary surface of A and this is the imaginary surface of B. The surface of A is bigger than the surface of B. Now what happened? There are the number of lines. Okay, these number of electric lines, electric field lines are passing through the surface of A, imaginary surface of A, and passing to the imaginary surface of B. But these and these line and these and this line are not passing through the imaginary surface of B. These two lines, this and these two lines are passing through the imaginary surface of B. So the electric field lines which are passing to the surface of A is greater than the electric field lines passing through the B. Okay, so here we can see that, okay, the number of electric lines, the number of electric line passing through the surface of A is more than the number of electric flux line passing through the surface B. Okay, now whatever the lines are perpendicular to the surface is only passed through the imaginary surface. Okay, so we can also say that we can also say that the electric field of the surface A is greater than the electric field of surface B, or we can also say that the number of electric flux lines are greater than the electric field is also greater of that surface. Okay, now the third property is known as the electric field lines are always perpendicular to the conductor. The electric field lines is always perpendicular to the conductor. Okay, now this is one conductor. Okay, this is a conductor. Now just one before, we have to see that the electric field lines are always perpendicular to the conductor, and you also remember that it also moving outside to the surface. Okay, it also moving the outside to the surfaces. Okay, now this is a one electric field, so electric field this surface and outside to the surface of the conductor. This is also electric field, it's a perpendicular and outside of the surface. This also electric field is outside the surface, this also electric field is outside the surface. So electric field lines is always perpendicular to the surface, but it is in outside of the surface. Okay, now the fourth property is electric field lines never intersect. Okay, so electric field lines are never intersect to each other. So one question is our mind, when the electric field line intersect with each other, then what happen? Okay, so let me explain one example. Okay, this is a electric field line 1 and this is another electric field line 1. These two electric field are intersect at that point. Okay, now as we know that the electric field are always tangential to the electric field lines. So the electric field is, this is a tangential electric field and these are tangential of these electric field lines. Okay, now we find out the electric vector on point P. This is a point P. Okay, but we know that electric field are always perpendicular to the field lines. Okay, or we can also say that it's a tangential to the field line. So electric field having two direction. Okay, so intersection of the electric field lines never possible. Okay, so the intersection of the field lines will never possible. Okay, now it is our fifth property. The fifth property is electric field lines are directed radially outward of a positive point charge and radially inward of a negative point charge. Okay, now so we can see that one example, it is a positive charge and these are the electric fields, these are the electric fields, these are the electric field, these are the electric field, these are the electric field. And as we know that electric field are always perpendicular to the surface and outward. If the positive charge are outward and the negative charge are inward. Okay, so the negative charge are inward, 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 inward and inward. Okay, so the sixth property is the electric field lines are exact lateral pressure on each other. So what is the lateral pressure on each other? So you can see that. Okay, now this is a positive charge and this is a negative charge. If the positive charge having the electric lines, these are the electric lines. Okay, these both are the positive charges. Okay, and these are the electric lines, but this electric line and this electric line has a pressure of the internal pressure and they oppose each other. So due to the lateral pressure on each other, they move away from each other. From this pressure, they are away from each other, and they are away from each other, so they never intersect. Okay, so they never intersect, and the principle of the repulsion is on the base on the lateral pressure is created on each and every electric field lines are exact to each other, so they are repel with each other. Okay, same the property number 7, electric field line have the tendency to contract. Tendency to contract means it is attract to each other, we can also say that. Okay, so this is here we can take a one positive charge and one negative charge. So the positive charge has a the positive charge has outward direction of the outward direction of the positive point charge, and the negative charge has a inward point charge. Okay, now these outward, these outward, these outward, these outwards of the electric field, this is outward of the electric field, this is the inward of the electric field, and this electric field is intersect with this and this contract with this, because this is outward but this direction of the negative point charge is inward, so this is a contract. This positive field is contract to this negative field. Okay, this is a for outward but this is a inward, so this electric field is contract with this field, and this electric field is also a contract to this electric field. So for the positive charge of electric field lines are radially outward, and for the negative electric field lines are radially inward. So electric field lines are originate to the positive charge and terminate to the negative charge. So it's unlike charges are attract with each other. Okay, and the last and final property is the electric field lines are never passes through a conductor. Oh, electric field lines are never passes through a conductor, because here we have a we draw a conductor. Now this is the electric field, and we know that electric field are always directed perpendicular to outward direction. This is also directed outward to the positive or outward direction. Okay, in this case there is no electric field lines are passing through the conductor. There is no electric field lines are passing through the conductor, so inside any conductor electric field is 0. So we can say that electric field lines are never passed through the conductor. Okay, I hope you enjoyed this session. Thank you.